now we have some time to really have not just questions, but actually have a conversation about those. So who'd like to start it off? Well, I came prepared. I believe it was John Liu this morning talked about how we're going to have things in different silos or stovepipes. You know, a stovepipe for the water system, a stovepipe for the energy system, a stovepipe for the transportation system. And I guess I'm not too sure who to ask this to, maybe the whole panel. But have you looked at, in your simulations, and we just heard some that maybe cover some of this, but the difficulties and the advantages of linking those stovepipes or those separate silos to get more sustainable and resilient solutions? Have you looked at simulation models that connect those separate systems now in ways that give us a wider set of opportunities as we plan and design those systems? Yeah, and it's, I mean, sorry, yeah. Maybe you can. Sorry, I love to talk. So, okay. We have, in scope of an other project, we have worked on some kind of unified simulation platform for building. Because usually in building you have simulation tools which are dedicated to thermal energy, thermal simulations. These are the main ones. But you need some to have some control command simulation. You need some to have some airflows simulation and so on. So what we try to do is to connect all these tools together. And there are some people in LBL which do the same, like Michael Vetter in LBL, who is working on these kind of issues. It's very intricate because when you want to connect the tools point to point, it's quite easy. Like you can perform some thermal and airflow combined simulation quite easily, combining the two proper tools. But when you want to have those holistic simulations, usually it's very intricate because it's not the same level of abstraction. It's not the same way of representing the information, the knowledge, and so it's not an easy issue at all, even from a software tool provider point of view. So maybe I can leave you to talk as well.
Maybe I think there's two questions. There's a question of modeling, and there's a question of data collecting and making data coherent.
Yes.
For the modeling, one question addressed in the CityNet project is the multi-level modeling, be able to have a local representation of the distribution network, for instance, and generalize the result on the global city. We don't have physical simulation as you, but there's an issue about modeling. The other issue is, for instance, in Bologna, we use transport data, we use some energy data, yes. We use their energy action plan. The energy action plan is an Excel file. All distribution network data are on a GIS database. Transport data are somewhere. We don't. It's even sometimes very hard to find it. So just from an ICT point of view, it's a big work, and we thank Bologna and Cesena, local authority, to help us to do it. It's a big work to together and make all these data coherent. Yeah. So that's two sides of the question.
I think the kind of I would reinforce this point. I think that it may be less. There's not a great history in planning of global total simulations. In fact, there's quite a storied history of the failure of such exercises. They tend to be termed failure only after enormous amounts of money have been committed to their implementation, either in bureaucratic or physical reality, or unfortunately sometimes both. I think the issue of interoperability is really and legibility of data to other data is really important. And I think one of the great things about operating in an urban environment is that one can speak, for example, of data being urbane. And urbane is a quality of being legible and intelligible and sophisticated and all of these things at once. And so having I think it's less important to have everything in one box than it is to have the people who are in charge of the different boxes meeting regularly and responsible for a set of shared objectives, which are firmly grounded in the reality of whatever situation it is. And that is very helpful in keeping some clarity about the simulation being a tool and not an end in itself.
Gabriel has a question here. And
yeah.
You have the microphone, so
It's Gabriel, regular phone. A question for all of you. When you run a simulation for a city, are you able to quantify, for instance, in dollars, the added value of running this simulation? Yeah.
That's the whole point of building the right models with the right data in it, so you can assess the results in a way that's usable by a city, so the decision maker can rely on something robust to take the decision. So you have to build the models that use the data from the place where it's been simulated, because the economics of the simulation would be different from a place to another. So there's always some local analysis to be carried out, but the whole point of running this simulation is to provide those kind of numbers. Otherwise, it's just science, which is great, but for decision makers, it's not enough.
Yeah. Well, one goal of the CityNet project is exactly to be able to quantify and to have key indicators about the impact of a given policy. I totally agree. There's a local question, but there's also a question about assumption. If you run simulation on 2020, big impact will be, for instance, gas price scenarios. But maybe the more important is the sensitivity of the result. You want to be robust for instance, you don't want to be dependent of a given energy solution. You want to be robust to that. So, but your question was maybe about experimentation in Bologna, Senza. We haven't. It starts next year, so I can understand maybe in 1 year.
François?
Yes, to make simulation, you have to couple models, and so in fact you are propagating errors from one model to another one. Did you try, or are you trying to assess the reliability of your results, in fact?
Usually it's by comparing. Sorry, no, maybe please. You like to.
No, go ahead.
No, please go.
All right, I'll be rude in American for a minute then.
In fact, at the beginning, we planned to have a fake argument, but we are not doing it.
Yes, exactly.
Okay, so please.
No, I mean, I think speaking again as a designer, I would, and as an urban practitioner first and foremost, and who's tried to make intelligent use of simulations in the realm of practice, I think your point couldn't be more important. That the tendency of there is a constant need to both test simulations against reality and also sometimes to ignore simulations. In a great urban example here in San Francisco is the demolition of the freeway that used to run around the outside of the city, where if you were in San Francisco as a tourist and saw this beautiful view down Market Street, there used to be a very ugly freeway cutting it off, and when it was damaged in the 1980s earthquake, there was a big move just to take it away completely. And all of the traffic simulations, all the traffic engineers came forward and showed kind of propagating impossible gridlock as a result of the demolition of the freeway, which of course didn't occur because there were more complex dynamics in the situation. Different people's decisions and values in a larger urban context ended up people were willing to take a hit or not drive or do all kinds of things in order to have a more civil, a more gracious, a more, in its own way, in terms of the democracy of access to the water, a more democratic city as well, instead of simply privileging those who choose to drive. I think that one of the great failures of simulation in the 60s and 70s, when it was very prevalent in American planning, was the restriction to single variables and the restriction to single situations, and then the coupling of simulations with no consciousness of what you just said, of the propagation of errors and inaccuracies throughout it. But the city, I think one of the things that I would speak up for in this context is the crucial status, and you refer to this with the work in Singapore, the city itself is a laboratory. If you look at the great urban renovators of the last 20 years, people like Jaime Lerner in Curitiba, or Enrique Peñalosa in Bogota, or now Sadakan in New York, there's an enormous willingness to experiment in the physical fabric of the city, to use the city to simulate itself, whether with the pedestrianization of Broadway, et cetera, So it's harder to do when you're dealing with infrastructure to experiment in this way. But I think but hard doesn't mean impossible. And I think one can always the crucial role of cities in our culture is as laboratories, and so that's I think a very important thing to remember in this particular context.
And if I may add something.
Please.
Thank you.
So, you were such a gentleman to go second.
Oh,
yeah.
Thank you. No, it's just about what we intend to do with the simulation. I mean, simulation is only part of the answer, right? Usually you use simulation only to have some kind of support in making some kind of decision. So this is how it shall be used. It shall not be used as a heavily reliable system which can tell you, like, in 2 hours we'll be in this situation, right? I mean, it's still up to the end user to choose, to make the final decision. So I think we have to keep this in mind, and especially because systems are getting more and more complex. So it's useless to try to have this very fine-grained modeling and simulation, which are supposed to take into account every little factor that can affect the behavior of your system. It is especially true in buildings, right? The insulation materials and so on are so complex that now it's very difficult to even model and simulate them. So basically, usually what is nice is to have some kind of mixed approach in which you try to model in a simplified way from the physical point of view the system you want to simulate, and then to rely also on some actual measurements which can help in calibrating the model. Right?
There's a quote I love that speaks to that by a professor from the University of Pennsylvania named Britton Harris, who was one of the leaders in urban modeling in the mid-60s, and he said, all models are wrong, but some are useful. Fair,
That's true.
So my question is about timeline of implementation, because you're doing your modeling, your simulation, to finally implement some solutions. And for instance, in the case of urban design, what is going to happen if you do one site 1 year and the next one 2 years ago, 2 years after that? Do you need to synchronize? And it's the same thing for energy optimization of neighborhood. Do you have a time constraint when you finally implement your solution? It's an open question. I don't have the answer to this. It's really...
Well, as far as the particulars of the urban design proposal I'm talking about that I presented, I would argue, and again, one of the really crucial things about decentralized approaches to infrastructure of the type that I'm advocating for is that if you do put in 20 stormwater retention sites this year and 2,000 the next year, you will never, unlike, for example, the high-speed rail program in California, where they're building one piece in the middle of nowhere first, you get something instantly when you start to build every piece of every small piece of a networked infrastructure. And not only that, you get something instantly, and then there is also a phase change when you get to a certain level of a certain scale of any kind of network paradigm, where things suddenly start helping each other even more. And so I think that particularly for example, the situation in New York and on the Eastern Seaboard last week, the consequences of more traditional approaches to energy and infrastructure within an increasingly unstable and uncertain urban environments were made very clear. So I think it's your question is a really important and really interesting one, that we have to conceive of solutions where each step of the solution achieves something. Because if certainly urban history is any guide, things are not ever implemented, and nor should they ever be implemented precisely as they're designed. And therefore, each part of the investment needs to pay off.
Right here, gentleman with the mic.
Oh, sure. Omar Sadiq again from EPRI. As you've all been presenting, I've been sort of thinking how public policy decision makers could take some of these very powerful tools that you've all are all working on and implement them. And it strikes me, and I'm just curious for your perspectives on this, that perhaps a useful way for that public policy groups to look at this is to help do stress testing on possible scenarios, particularly for high impact but perhaps low probability events, rather than perhaps very trying to get to a point of very fine predictability of outcomes, just to perform that kind of scenario testing. That was one question. I love your thoughts on that. The other one was with respect to, I think it was the last presenter, on the district level model simulation and optimization. Maybe it's obvious to everyone else, but perhaps not so much to me. What was the optimizing function? I mean, were you optimizing for energy or environmental outcomes? And because there are surely trade-offs between one or the other. So those are two questions, one for the whole panel and one for you, please.
All right. So which one would you like to begin with?
Can start.
Yeah, so we start with the second one then. So the focus is clearly on energy. So basically, well, CO2 emission, like, it's also a parameter, but what is the main parameter is energy and to decrease consumption. Of course, we intend to take into account a lot of factors, including the price of energy on the external grid. But, well, basically, I think the main challenge is to be able to cope with these combined production units, because you have to make a trade-off. Since you are producing two flows, you have to know what to do according to the storage facilities, state, and so on and so on.
Maybe to answer your first question, I'd go back to Gabriel's first presentation we had this afternoon, where he had this pyramid for, like the Maslow pyramid for a city, where there was the attractiveness and the resilience. And maybe we could think of like the attractiveness as the average price of living in a city, or attractiveness of the city in like many ways. And what you're suggesting is that we look at the resilience also, in case of like a stress scenario, is more how the city would behave. But once you've modeled the city, you can run simulations for the average value or for like the lowest 5% case scenario. So it's all about like building a robust model that works across all spectrum. And once you have that, you can obviously deliver the results that make sense for the city.
One final question from way over here.
Yeah, hello, good afternoon. Thank you very much for very interesting presentations, and I mean, obviously for the entire day. My name is Sergio Altomonte. I'm from the University of Nottingham in UK, but I'm visiting here at the College of Environmental Design. I have to say I'm an architect, so I'm really interested in the design aspect of the city, obviously. Maxime at the beginning started talking about the city as a complex organism. And complexity was a word that came up a number of times in all your presentations. Obviously, here the focus has been on optimization and energy efficiency. But considering the city as a complex system that requires, obviously, a multidimensional and multidisciplinary approach, I would like to ask to the panel, what are the challenges that you think are there for city planners, urban designers, policies, and obviously also the citizenship of all of us in dealing with these questions, and how you can communicate results of simulation and modeling technique to people that do not necessarily speak the language of energy efficiency or modeling and simulation.
This one is tough, right? You answer.
I mean, it's a very important question. I think the level of, it was actually the American urban theorist, you probably know Jane Jacobs, who first, only because she was sharing space with a mathematician who was head of the Rockefeller Foundation at the time, when she was writing Death and Life of Great American Cities, she wrote about that the city might be one of these very new problems at the time that science was unpacking, which is the problem of what was termed at the time organized complexity, now just complexity. One of I'm a sometime collaborator actually with, related to your question, with Jeff West and Louis Betancourt of the Santa Fe Institute have looked into these fundamental scaling questions and the network nature of cities. And it's very clear that cities are their own kind of, for those not familiar with the research, cities are their own kind of efficiency machines, like metabolisms that scale in certain ways and exhibit certain properties, and that all of our best efforts as designers or infrastructuralists often bounce off this kind of underlying urban reality. And so I think that especially in such a situation, I think the emergent nature of cities actually in some ways relieves us of the burden of master planning, since master plans are destined to be very ineffective in an urban context. I think instead we better conceive of our efforts as to how do we tap the emergent nature of cities to solve the problems of cities. That is to say, how do we make, so for instance, something like data interoperability becomes absolutely essential when we're talking about data in the city, because any one player in an urban landscape is guaranteed not to hold all the data necessary to envision the future of that urban landscape, or particularly tap and therefore the ability of, and neither is any single player going to pull all the right data together, but the right data will potentially come together as a consequence of the individual actions of many players in the cities. As a more concrete example, data interoperability has been a huge push, for example, inside the Bloomberg administration, amongst all the different departments of all the different players in the urban landscape, and they've used very effectively emergency management as a kind of cudgel to get everyone to make their data interoperable, not because they really believe that emergencies are the most important circumstance in which data becomes interoperable, but it's the biggest bureaucratic leverage they have, is to say you don't want to be the one who gets in the way of emergency management. So I think that, I'm not sure this quite answered your question. I think your question may be sufficiently profound that it's unanswerable within the format of something like this panel. But I think that this complex nature of urban problems is non-trivial in the conversation, and it's something that we need to orient our solutions towards, instead of as was often the case with the kind of simulation exercises in the 1960s and 70s, which radically oversimplified the city in order simply to be able to simulate it, which was understandable but nevertheless tragic in its consequences.
All right, please thank me for these 4 fine presentations.